Jelly Spoons, welcome back to Badgerworks. Today, circuit boards. We're going to look at circuit boards today, but very specifically, not this circuit board. This is actually a USB charging circuit. But what we're going to do is we're going to make our own circuit board. Now, I have a requirement for a specific circuit board, one that is 70mm in diameter and has 4 ultraviolet LEDs fitted. So I'm going to make one, and I'm going to show you how to do it. So what I've got here is a whole bag of circuit board blanks. These are basically offcuts from a company that makes circuit boards, and they sell the offcuts to people like me. So what we've got here is, it's basically a piece of plastic with a copper coating on one side, and we're going to use this to make our circuit board. So the first thing I want to do is mark a circle on here, 70mm in diameter, and cut it out. So to get our 70mm diameter, we set the radius on the compass to half of that distance, 35mm, and we draw a circle. I'm going to give that a little dig in the middle because we're going to need the centre point again. So I'll go and cut that out on the bandsaw. Back in a bit. So there's our little disc of circuit board. Now what we need to do is lay out where we want the actual circuits, and to do that we use this. This is a circuit board pen. Now it looks like a felt tip pen, and that is effectively what it is, but basically it's used for masking where we want the circuits to be. I'll show you what I mean. So, what's the purpose of this line? Well, what we're going to do is we need to remove the copper from the circuit board where we don't need it, where we don't want a connection. And to do that, we're going to acid etch the board. So we're going to put this board into acid, and the acid will eat away the exposed copper. So by masking off part of the copper with this line, what we're actually doing is leaving behind the copper where we need a circuit. Now, because I need to put LEDs on this and resistors, I need to lay out where they're going to go. So here are the LEDs. These are surface mount LEDs. They're 1206s, and they are, as you can see, if the camera will focus on them, they are tiny. Absolutely minute, but they are the ideal thing for this application. Now, because we're going to be running these LEDs on a 12 volt power, we also need some resistors to lower the voltage. The forward voltage of these is about 2.6 volts. So I'm going to use these 1206 resistors. These are 470 ohm. Now, to be honest, I tend to use these for everything. They work really well. Now we could use Ohm's law and calculate exactly what resistance we needed for these particular LEDs, but I know that these ones will work. So that's what we're going to use. So to lay it out, we need 4 LEDs and 4 resistors. Now these things are absolutely tiny, so you need a pair of tweezers. These strips are actually designed to be fed into a machine. That's what the holes are for. So they're driven by a stepper motor. So trying to solder these things by hand is like redecorating your house with a letterbox. but there we go. So I don't know if the camera will actually focus on that or not, but that is the LED. It's absolutely tiny. Fun. So what we need to do is take that, and we need to put it in a position where it will cover the gap that we want. So what I'm going to do is I'm going to put the LED round this way, like this. So the resistor needs to go here, touching the line, because it's going to be soldered to that circuit. And we're going to come down, we'll have another little mask bit here, which I'll show in a second. We'll go across, down again, and then we'll have another circle inside. So we'll have one for positive, one for negative. So now we can take our pen and we can mark the inner line. Now we can pop the pen out of the compass and we can mark where we want. So we want one there, one there, one there, and one there. Now obviously I'm just doing this by eye, but you get the point. So what we need to do now is we need a line here. We need a line here to join the two together. And now if you see, what we've got is a circuit that will carry the power from here to the resistor, through the resistor, to the LED, and then to ground. So now we need to do 4 more of those. And there we go. Now, of course, what we also need is somewhere to connect the wires. So what I'm going to do is I'm going to draw freehand just a little box here, and another little box here, and the inside one will be negative and the outside one will be positive. So now for the fun part, what we need to do now is etch this board, and I'll show you how to do that. So what I've got here is a small tub of acid. This is ferric chloride. It's a 40% solution, and it is sold specifically for this purpose. It's PCB etching solution. So what we do is we take our circuit board and we put it carefully into the solution, and then we just leave it. The ideal solution is for this solution to actually be slightly warmed, although it is quite warm in here today anyway, so that should help. And also you want to agitate it. Just basically just keep sloshing about, and the idea behind that is that as it eats away the copper, you want to keep washing the copper off of the surface. So basically the way I do it, because I like to keep an eye on it, is just to keep rocking it backwards and forwards like this. And that will actually eat the copper off of the board, but where it's masked it will leave the copper behind. as we will see in a moment. Now, I don't know if you can see that, but that's actually already started eating away the copper. You can see the copper's changed colour. Now, the strength of the solution, the temperature of the solution, how much you agitate it, all these kind of things will affect how long it takes to etch the board. But normally I find it takes about 10 or 15 minutes. So I'll etch this and we'll see what happens at the end. Back in a bit. So this has been in here now for about 5 minutes, and as you can see, it's clearly eating away the copper around the edges of the board. The copper's changed colour, and that's the great thing about this, is the acid will eat away the copper, but it doesn't touch the plastic, which is also why I can keep it in this plastic tub. Now, of course, the thing to remember when you're doing this is that this is acid. It's a fairly weak solution, but it is still acid. And you don't want to get it on yourself. You don't want to get it on your skin. You certainly don't want to get it in your eyes. Don't drink it. It's nasty stuff. Now, so yeah, safety precautions, glasses and so on. Also, when you're done, don't tip this stuff down the drain. Okay? Firstly, it's illegal to dispose of it in that fashion, and secondly, it's stupid, because this stuff, as you can see, is designed to eat copper. Now, the pipes in your house are copper, and if you tip this stuff down the drain, it will eat away the copper pipes in your house, and you will end up with water leaks. So yeah, don't tip it down the drain. When you need to get rid of this stuff, which you will eventually, because it will become less and less effective each time you use it, basically what you need to do is contact your local authority, the council or whoever, and explain to them what you've got, explain to them it's only a small amount, and ask them what to do with it, and they will probably tell you to take it to your local council waste disposal site, and there'll be somewhere there you can dispose of it. But yeah, don't tip it down the drain, please. So this has been in here for about 10 minutes now, and as you can see, the copper is coming off very quickly now. So yeah, we just keep at it, just keep agitating it, tipping the pot backwards and forwards, and another 5 or 10 minutes and that'll be exactly where we want it. And there we go. After about 20 minutes in the pot, all of the copper is gone, all of the exposed copper is gone. Now we're going to wash it off and we'll see how we did. So there's our circuit board. As you can see, all of the exposed copper is gone. What I'm going to do now is take a cotton bud and some cellulose thinner and wipe off the remaining ink, and we'll see how we got on. And there we have it, a circuit board. So what I'll do now is solder the components in place and see if it works. Now I can imagine you're watching thinking, how on earth are you going to solder these tiny little components onto this board? Well, I'll show you. I'm going to use a manual version of an industrial process known as ball soldering. So what we do is we just take our solder and a pair of clippers and we just cut off tiny little snips. I mean, these are literally about, I don't know, maybe a millimetre and a half long of solder. And what we do is we take our soldering paste and a little brush, and we'll start here, and we put a little blob of paste there and a little blob of paste there, like that, and we take our tweezers and we take one of our resistors and we drop it across the gap like that. Make sure it's touching both sides. Then we take one of our little bits of solder and we pop that in place as well, like that. Now we take our soldering iron and we touch, and there you go. Then we take, now this is where it starts to get interesting, because now we need to solder two components together. So again, a little bit of soldering paste on there, a little bit there, and we take one of our LEDs. Now the thing to note with these LEDs, and I don't know if you can actually see that or not, probably not, but on the end, on one end, there's a little green arrow. The green arrow goes to ground. So then we take another piece of solder, we put it in the middle there, and we touch it with the soldering iron and it solders. Then the same at the other end, we take another little piece of solder, put it in place and touch it with the soldering iron, and you see exactly what I'm doing here. And there we go. So now I can test this and just make sure it works. And there you go. Obviously it's dim because this is only a 3.7 volt battery, but that works. So now we move on to the next one. Same again. Little bit of flux on each side. Take a resistor. Now the resistors, it doesn't matter which way around they go, as long as they're touching both sides. That's the most important thing, because if they're not touching both sides, it will not create a circuit. Same again, put the battery on it, just check it. Make sure it's soldered properly, which it is. On to the next one. The soldering paste does several things here. Firstly, it obviously does its normal job of helping the flux, it acts as a flux, sorry, to carry the solder into the joints. But what it also does is it acts almost like an adhesive, and it's just holding the components in place while we solder them. When you're putting these LEDs in place, be very, very careful, because if you press on them too hard, they'll break. So just be very, very gentle with them. Another quick check. I like to check after every light just to make sure, yeah, that works. And oh, run out of solder. Nearly got. Oh no, there's one bit we need. I was one piece short. There you go. Okay. And last but by no means least, And one final check. Yep, all four work. So there you have it. That's how you make your own circuit boards. And especially when it comes to soldering surface mount devices, which are normally intended to be soldered by a machine. So I hope this has been of interest to you. This is obviously something that's very useful for me. And I'll see you on the next video. Thanks very much for watching. Thanks, bye. One final thing, in case you're wondering what the circuit board was for, it was for this. A Nuka-Cola bottle stand that I made for my son. Anyway, yeah, thanks very much for watching. Bye.